Hello again, Math 10Cs. In today's lesson, we're going to continue to look at the relationship between two quantities or variables, which was something we did in the previous lesson. We had a couple of variables and we plotted them on the x-axis and the y-axis, specifically the manipulated variable on the x-axis and the responding variable on the y-axis. And then we start to look at the relationship between them, and we're just going to continue to expand upon that in this lesson. Now, the first 3 pages of this lesson go through a lot of theory and some definitions, and rather than me just reading through it one page at a time, I'm actually going to skip ahead to the 4th page, and then I'll start to make reference to any of the theory as it comes up. I feel like that will be a more efficient use of our time. Okay, so let's skip all the way to page number 4. And let's go down to the bottom here. By the way, if you're wondering why there's that smart notebook thing, basic version, it's because I'm using this program at home where I only have the basic version. So you just have to deal with that annoying little background. Okay, so let's go to this equation. So we have y is equal to 3x minus 5. Now, this equation that relates y and x together, we refer to that in math as being a relation. The variable x is what we call the independent variable, or the name that I was referring to it as in the last class was the manipulated variable. And the manipulated variable just represents your x values, which again, you plot on the x-axis. The dependent variable, I refer to it as the responding variable. We can also call it the dependent variable. The reason it's called the dependent variable is because it depends on what the value of x is. So we can actually use this equation to plug in different values of x to determine different values of y. So let me give you an example. Let's say that we plugged in x is equal to 2 into this equation. So if I sub it in here, it would be y is equal to 3. And then in the place of x, I'm going to replace x with 2 in brackets, and then subtract 5. And then 3 times 2 would be 6, minus 5 would be 1. So the reason it's called the dependent variable is it depends on which value of x you actually plug into the equation. If I change it to a different value of x, like for example, x is equal to 4, then you'd have y is equal to 3, and then replace the x with a 4 this time, so 3 times 4 minus 5. 3 times 4 would be 12. 12 minus 5 would be 7. So it's completely dependent on which value you actually plug in for x, hence why it's called the dependent variable. Now, these values I was looking at here, so if we look at, for example, the x values of 2 and 4, those are values that I'm inputting into the equation. So we can actually refer to them as being inputs of the relation. The values of y that we're calculating, that's what my output is as a result of like plugging those x values into the equation. So your y values in the relation, we refer to as the outputs. Let's look at a few examples now where we are going to identify independent variable, dependent variable, inputs, and also outputs. Okay, so we have three different types of ways we can show a relationship. So this weird diagram with the two ovals is what we refer to as a mapping diagram. It's probably the only diagram that you may not have seen before. So I'll explain that one in a moment. I'll just go through the other two ones first. Okay, let's deal with the part C first. So part C has an ordered pair, B comma C. Ordered pair is always in the form X comma Y. Now, part I says state the independent variable. Well, the independent variable is just the X variable. So that's going to be capital B. The dependent variable would be the Y value. And the Y variable is C here. Okay, so 3 says list the inputs. So the inputs would just be all the different X values we have. So this 3, this 4, this 5, this 6. Those would all represent inputs. And then this 7, this 11, this 15, and this 19, those would all represent my outputs. And I believe we're using 3 to represent the inputs, and we're using 4 to represent the outputs. Okay, so that's part C. Part B, whenever you're given a data table, data tables are always going to have the manipulated variable listed first. That's going to be the X value and the Y value second, just so you can write them as an ordered pair. Therefore, V here would represent the independent variable, and A would represent the dependent variable. These different values of X that you have here, those would be your inputs. So I could label that as 1, 2, 3. And these different values of Y, that would represent my outputs. So I'd have 4 to represent that. Now, the way a mapping diagram works is the values in the oval on the left-hand side, those are going to represent my X values. The values on the right-hand side, those will represent Y values. Therefore, P here would be your independent variable, and Q would be your dependent variable. If you want to take this mapping diagram and write the mapping diagram as a set of ordered pairs, we could do that. So we could write down as an ordered pair, P comma Q. And then you kind of just follow the map to write down the ordered pair. So if we have an X value of 5, follow the arrow, that would give me a Y value of 10. So you have 5 comma 10. And then if you have an X value of 8, you'd have a Y value that is 16. And if you have an X value that's 11, you'd have a Y value that would be 10. Okay, so therefore, we can just highlight this. These are all the X values. So that's going to be your inputs. And then these values over here, those are all the different Y values. And those will represent the outputs. Okay, let's go down to the third example. Okay, so it says the diagram show relations expressed in different ways. In each case, identify the independent and the dependent variable. All right, so This one, the first one, this is an equation for the circumference of a circle. So the circumference of a circle is equal to 2 times pi times r. Now, it turns out here that r is the independent variable, and then capital C would be the dependent variable. And that makes sense. The circumference of a circle depends on what the radius is. If you have a circle with a bigger radius, you're going to have a larger circumference. If you have a circle with a smaller radius, you're going to have a smaller circumference. This one, you have a graph. And as mentioned before, we always put our x variable on the horizontal axis, and we always put our y variable on the vertical axis. Therefore, your height would be the dependent variable, which is 2, and the time would represent the independent variable, which would be I. C says the amount of sap S obtained from a maple tree is dependent on the time t that a container is left on the side of the tree. So this sentence actually flat out tells you what the dependent variable it is. It says the amount of sap depends on the time. So the amount of sap here would be your dependent variable. And then the time would be your independent variable. So the longer that you leave this container on the side of the tree, the more sap you're going to collect. Therefore, the sap depends on what the time is. Okay, let's look at this in terms of some more complex graphs. Okay, so we have a linear relation, which is given by the equation y is equal to 2x minus 5. And what part A wants me to do is it wants me to fill in the first 5 rows of this table. The way we're going to do that is we're going to take these input values and we're going to plug them into the equation and then determine what the output or the y value is going to be. So when x is equal to -2, if we plug this into the equation, we'd have y is equal to 2. Now we're going to replace x with -2 minus 5. So 2 times -2 would be -4, and then -4 subtract 5 would be -9. Therefore, my output would be -9. And if I write this ordered pair down, it'd be -2 and then -9. Now we're going to use a different input. We're going to put x equals -1. And that'll be y is equal to 2. We're going to replace x with -1 this time around. We're going to subtract 5. 2 times -1 would be -2. And then subtract 5 would be -7. Third input, we have x is equal to 0. So I'd have y is equal to 2. And then multiply by 0. And then subtract 5. 2 times 0 is 0. Subtract 5 would be -5. Okay, let's fill the table in. So we got -7 here. So that'd be -1 and -7. And then here we have -5. So this would be 0 and -5. We could get these two remaining outputs by just subbing the numbers into the equation, but at this point you can actually identify a pattern that's occurring. So if you look at the input is increasing by 1 every time you go to a lower row. And what the output's doing is for every increase in 1 by the input, the output is increasing by 2. So from -9 to -7, you increase by 2. Add another 2, you get to -5. Add another 2, you get to -3. Add another 2, and you get to -1. So you'd have 1, -3. And then here you'd have 2, -1. Okay, so that's part A. Now, part B wants me to plot these points on the Cartesian plane. Okay, so the first point that we have is, let's go up here and take a look at it. So the first point is -2 and -9. So that means go to the left by 2 and down by 9. So we're going to be somewhere down here. Okay, and then we have -1, -7. So go 1 to the left and then down by 7. So be located at, here, let's get this smart notebook thing out of the way. It's annoying. Okay, -1 and -7. Then we have 0 and -5. So start at the origin, go down to -5, which would be right here. And then we have 1 and -3. So go 1 right and then 3 down, located at this position. And then we have 2 and -1. So we go 2 to the right and then 1 down, located right here. Okay, now C wants us to draw a line that best fits through these points. Okay, so I'm just going to grab a line using a drawing tool here. You would need to use a ruler to do this. And again, please use a ruler to do a straight line, so it actually looks straight. You shouldn't be doing straight lines as freehand sketches. Okay, so I think my line might look something like this right here. Okay, that's pretty good. And it says also at the end of the line, draw some arrows. Okay, so if I go ahead and draw some arrows at the end here, I'd have an arrow that points down and towards the left. What the arrow means is it means that the line just keeps going on forever in that direction. And if you go up to the top here, you'd have an arrow that's going to point up and towards the right, which means the line just keeps going up and towards the right. Okay, it says use our graph to determine the value of y when x is equal to 6. Okay, so let's go down here. And okay, when x is equal to 6, that would be located right here. So what I would do is I would then start at x equals 6, and then I'd go up to my line. So I'll draw some dashed lines to go up there. So go up to the graph, and it looks like it hits at about 7 here. And then we go across to figure out what the y value is. So it looks like it's hitting at when x is 6, y is 7. This is what we call an extrapolation of the data, because I'm using the line to make a prediction outside of my 5 data points. So I can even write that word down here, extrapolation. Okay, so y is equal to 7. Part E wants me just to use the equation. We have to verify this is correct. So our equation is y is equal to 2x minus 5. And we're going to verify this is correct just by plugging x equals 6 into the equation. So when x equals 6, this would be y is equal to 2, multiply by 6, subtract 5. 2 times 6 is 12, minus 5 would be 7. So you would have y is equal to 7. So it is confirmed. F says write the value of y when x equals 6 in the table of values using that first blank space. Okay, no problem. So it just wants us to write down what the ordered pair is. So here, when x equals 6, y equals 7. So he's got to fill that in. 6, 7, write the ordered pair, 6, 7. Let's go down to G. It says use the graph to determine the value of x when y equals 3. So this time we're going to start on the y-axis and go down to the x-axis. We're still going to extrapolate because we're outside of our data points. Okay, so y equals 3 here. So I go towards the right. And then I go down. And it looks like when y is 3, x would have a value that is 4. And it also says write this in the table of values. So when x is 4, y is going to be 3. So we'll go up here and we'll show that. So this is part G. When x is 4, y is 3. And then write down the ordered pair, 4, 3. And the final part is just to fill in the blank. It says complete the following statement. This relation is called a blank relation because the graph of the relation is a straight line. We called it a linear relation. Just look at the first 4 letters of the word linear. It spells out line. So a linear relation is just going to be a relation where if you have 2 variables, an independent and dependent variable, and you plot them, you can fit a straight line through the data point or approximately fit a straight line through the data points. Now let's look at a different type of relation, for example, 2. So this one's a bit tougher because now you have y equals x squared minus 6. So I have an exponent attached to the x. Okay, so it says complete the table of values to the right, which shows some of the possible input values. Okay, so let's just go up here. Try to get that text out of the way. Okay, so we need to just use the equation and input x into the equation and see what the output is. So we'll start off by doing x equals 4. Okay, when x is 4, y is equal to, plug these numbers in brackets. So you'd have 4 squared minus 6. 4 squared is 4 times 4. Minus 6 would be 10. So when x is 4, y is 10. 4, 10. All right, when x is 3, let's plug it in. You get y is equal to, so this time we're going to plug in 3 in brackets, and we're going to square it. Subtract 6. 3 squared is 3 times 3, which is 9. Minus 3, or no, minus 6 would be 3. So you have 3, 3 as the ordered pair. Then we plug in x equals 2. So when x equals 2, replace the x with a 2, and we're going to square that. And then we're going to subtract 6. 2 times 2 is 4. Minus 6 would be negative 2. So you got 2 and negative 2. At this point, you might be wondering if you can fill the rest of the table in just by identifying a pattern. Not for this relation, because the problem here is that as your input values decrease by 1, so you go from 4 to 3, 3 to 2, 2 to 1, your output values don't change by the same amount. Because when you go from 10 to 3, you subtract 7. And then when you go from 3 to negative 2, you only subtract 5. To identify a pattern, easily identify a pattern, you want it to change by the same amount. So to get the rest of the outputs, we're just going to have to plug the numbers into the equation. Okay, so we have when x is 1, we'd have y is equal to 1 squared minus 6. 1 squared is 1 times 1, which is 1. 1 minus 6 is going to be negative 5. So I'd have 1, negative 5. And then I have x equals 0. So I'd have y is equal to 0 squared minus 6. So that'd just be 0 minus 6, which is going to be negative 6. Okay, now I gotta be a bit more careful now when we get into the negative numbers. So we have x is negative 1. Okay, so we're gonna plug this in now. So when x is negative 1, we're gonna replace x with negative 1. Now, when you sub these numbers in, you must always sub them in brackets. Okay, the significance of this is that if, for example, you have negative 1 and it's squared, that means you're taking negative 1 and you're multiplying by negative 1, which would be equal to positive 1. So this would be positive 1 minus 6, which would be negative 5. I'm just mentioning this because if you plug this into your calculator, you need to write it in brackets. If you don't, like for example, if you typed in negative 1 squared, what the calculator thinks it's telling you to do is it's saying just do repeated multiplication of the 1, but not the negative. So the calculator would actually just carry out negative 1 times 1, which would be negative 1. And that's not the same thing. Okay, so again, anytime you do substitution, it's always in brackets. Okay, so we have negative 5, and I have 1 comma negative 5. And then we have x is equal to negative 2. And then we'd have y is equal to negative 2 squared minus 6. So y would then be equal to, so negative 2 times negative 2 is positive 4. Subtract 6 would be negative 2. So we have negative 2 comma negative 2. And then our final point, our final input, we have x is equal to negative 3. So when x equals negative 3, I'd have y is equal to negative 3 all squared minus 6. Negative 3 times negative 3 would be positive 9. Positive 9 minus 6 would be positive 3. So this would be positive 3, and we'd have negative 3 comma 3. All right, part B wants us to plot all these points now. Okay, so let's go ahead and do this. So our first point is 4 comma 10, so that means you go 4 to the right, 10 up. So that point's located all the way up here. The second point is 3 comma 3, so you'd go 3 to the right and then 3 up. So that's going to be located there. Third point is 2 negative 2, so you go 2 to the right and then 2 down. So we're below the x-axis now, so right here. And then 1 comma negative 5 means go 1 to the right and 5 down. So we're all the way down here. And then we have 0 comma negative 6, which means start at the origin and just go down to negative 6. So it'll be right here. And then we have negative 1, negative 5, so go 1 to the left and 5 down. Right here. Negative 2 comma negative 2, 2 left, 2 down. Going to be right here. And then we have negative 3 comma 3. So we go 3 to the left and we go 3 up. So located right there. And then we have negative 4 comma 10. Oh no, we don't have a point there. We have to do that in a second. Yeah. Okay, it says use the symmetry of the graph or table to predict the value of of y when x equals negative 4. Well, I already mentioned what it is, but you can actually easily see this just by looking at the symmetry of the graph. So if you think of the y-axis as being like a mirror, you have like a mirror image on both sides. So what that means is that each of these points on each side of the mirror are the same distance from the y-axis. So these two bottom points here are each 1 unit away from the y-axis. These 2 points here are 2 units away. These 2 points would be 3 units away. Therefore, at the very top right here, if this point is 4 units away to the right, then the other point here must be 4 units to the left. Therefore, I'm going to have y would be equal to 10. D just wants us to confirm that with the equation. So the equation is y is equal to x squared minus 6. So if x is equal to negative 4, and we plug it in here, we'd have y is equal to negative 4 all squared minus 6. So that would be negative 4 times negative 4 would be positive 16. Minus 6 would indeed be positive 10. So it is confirmed. E just wants us to write that in the blank on the table. Okay, so this means when x is negative 4, y is going to be positive 10. So let's go up here and I'll write that. When x is negative 4, y is positive 10, negative 4, comma 10. Okay, F, this is a bit tricky to do. It says connect the points on the grid with a smooth curve. So We can't do a straight line here because there's no way you can get a single straight line that passes through every single one of these data points. So I need to use a curve to do this. Now, this is actually really hard for me to do in a drawing tablet. This might be easier for you to do freehand. Okay, so I'll start down here and then kind of like curve going all the way up. Okay, and it's not bad. Put some arrows at the very top there, and then do it in the other direction as well. So we kind of curve, and then we go up, just like that. Okay, so that's a good smooth curve. One thing you want to avoid doing when you're drawing a smooth curve is don't feather it. And by feather it, I mean like don't like draw like a bunch of like little like kind of like individual little like lines like this, like little like sketchy lines. Okay. The problem with that is then the graph's not continuous. It has like little gaps between them, and that's not right. It should be a single smooth curve. So I'm just going to make the note here: do not feather. Okay, and then the final question just says, why do you think this relation is called a nonlinear relation? Well, because you can't put a straight line through the data points. Straight line cannot fit through the data. So something other than a line would need to do it. Okay, that's it for this lesson. You can do, starting in the next page, which is page 406. Numbers 2, 3, 5, 6, and for 7, just do A and C. And I'll talk to you in the next lesson.